right, I'm back. Okay. So, am I on the camera feed? If you want to hit the.
No, I'm on the game capture.
Game capture. Okay.
Yeah.
All right. So, hello everyone. We are now in the International Space Station, and we are going to go on a tour of the ISS. So, if anyone has any questions during this tour, please put it in the chat, and I'm just going to do my best to, if you watch an ISS tour, to show you around and interact with some elements that we see out here, and then maybe we'll end with a spacewalk. So I think there's a couple people from the virtual reality camp in this camp as well. So I've already seen this application. However, we're going to do a more full-fledged tour. So you can see me in the webcam. I'm in virtual reality, and I'm going to float around just like the astronauts would. Of course, I won't be floating in real life, sadly, but I will be floating around in the space station. You can see my hands out here. I can give you all a thumbs up. There we go. And you see these handrails. These are placed all over the ISS so they can maneuver around. Because obviously there's no walking, right? It's a zero gravity environment. So I can rotate myself around like the astronauts would. And the other cool thing about the structure of the ISS is that there's really no up or down. You'll find things all over the walls. Every wall has a purpose, and it doesn't really matter what way you're facing. You can always reorient yourself to look at the wall from a different perspective.
Is it the audio?
What did you say, Tierney?
She said she doesn't understand.
So they shouldn't be listening over Zoom.
Okay, don't listen over Zoom. Just listen over the YouTube. You may have to turn up the volume on the YouTube channel. Is on?
Stop for a minute, Jen.
You can put that in the chat too if they can't hear that instruction. I would put that in the chat to say listen over YouTube rather than Zoom. Don't leave.
It's echoing really bad.
I think that's because of well, no, that wouldn't make
Turn
sense.
off one of the lights.
I would just make sure the Zoom mic is off and.
Yes, and then okay. Your mic is off.
Okay, so let me know if it's still echoing, and we can work on that. But let's just start touring around, just so we don't waste too much time here. And you can see I have this tablet, and it is a map of the ISS. Now we only have the Japanese, the US, and the European modules. We do not have the Russian modules to explore in this one. For whatever reason, they just don't have them accessible in this application. But if you look at the map, we have Columbus here, which is the European Space Agency module, Node 2, and there's 3 nodes. So we're in Node 2 right now. There's the Kibo module, which is the Japanese science module. Destiny is the US science lab. Then there's the Airlock chamber, where maybe we'll find some space suits. And then Node 1 and Node 3. So we're going to tour each of these and see what the astronauts do in them. All right, let's go into the Columbus module first. We're going from Node 2 to the Columbus module. I'm going to grab this rail and just float on in. This is the European laboratory. And there's a bunch of equipment in here. Now, one thing we can do is interact with some of these larger pieces of experimental equipment, like this piece of...
Sometimes we call it the monster.
This is Italian astronaut, I can't remember her name now.
The purpose of monsters is to study muscles, and in particular muscle.
I apologize, I can't remember her name. Usually it gives it
Now it's
right here.
all tucked
But she's an Italian astronaut, and she's explaining the muscle atrophy research and exercise system, or MARES for short. So it's a muscle measurement machine on the ISS that monitors astronauts' muscles as they work out. We'll see several pieces of exercise equipment as we move about the ISS. You'll see camera equipment as well, because they do their own programs and their own tours, which again I recommend you check out. And there's also some lab equipment in here. There's one
This
piece.
is MELFI, or minus 80 lag freezer ISS.
This is called the MELFI.
In particular, this is MELFI 1.
And it
we
is
have
used to
two
store
more
a
MELFIs
variety
on
of
the space
experimental
station, another
samples.
here in the GEM, and one over in the
below,
lab.
that are
They
below
allow us
breathing
to keep
temperature.
samples
Then the hope is
frozen
that eventually
in
they'll make their way
until there is an
back to
opportunity
Earth.
to return them to Earth. They can
And again, notice each wall has a unique piece of equipment on it, and they all serve a purpose. There's handrails all over, so I can manipulate myself to each wall and rotate myself, because each wall has a different orientation. Like, I don't want to float over here because there's a chair, right? Now, I wouldn't really feel the difference of this, but visually I can tell I should be facing this way, because this is a chair. And I need to be sitting down in that chair, like that. So it makes, like, and then again here, this is, you can bring up the information about this lab equipment. Here's Scott Kelly during the Capillary Beverage experiment, which studies the process of drinking from specially designed space cups that use fluid dynamics to mimic the effects of gravity. Right. I don't think it's going to let us, but you can imagine how this works, right? You've ever been in a lab before, especially a chem lab, they'll have pieces of equipment like this where you can safely work on a sample, stick your hands through here, maybe there'll be some gloves, and that way you're not contaminating anything and it's not going to contaminate you. Alright, so that's the Columbus module for the space station, the European Space Agency's module. There will also be patches all along the walls from the various missions that have been flown. We're going to keep our eye out for both, well, any local astronauts that we know that have visited the ISS, so like Douglas Hurley or Dan Bursch. But we're also going to look out for, because I don't think this is his first mission, right? Chris Cassidy? He's been there before, right? So we're going to look out for Cassidy as well and see if we can spot him on any of these patches. So we'll look at those up close too. Let me make sure that there was none behind me. And let me check in with all of you. How's this coming across? Does anyone have any other audio complaints or?
Not yet. We got 18 people watching right now.
Okay. So it seems like things have smoothed out at this point, which is good news. All right. So nothing there. Let's go up top here and look at the patches. Some of them are better resolution than others, but I can probably make out most of them. Here we're going. Now these ones probably are mostly European. There might be a couple American. Okay, so maybe as we head into the US module, but let's go fly through node 2 again. Here's an airlock down here. Another one. Oh, there's some patches up there we'll go inspect in node 2. We'll go to the Japanese module next. Oh, there's a couple over here. They're just everywhere on the space station. Well, Collins. There's Collins. That's Eileen Collins. And Kelly's on here too, I guess on that same mission, which isn't local, but there's Kelly again. This one hard to read. Pattern. Nope. Okay. Well, we found Eileen Collins from Elmira. Over here. There's Kelly. Feel like how many missions has Cassidy flown?
This is the second one.
Oh, look at there he is. Just as we're talking about it, so here's Chris Cassidy.
Hey, Chris.
That patch. That is 127. Is that an STS 127?
Yeah.
Okay. There's STS 127. He flew aboard. Chris
I was
Cassidy.
flying with Hurley.
Oh yeah, there's Hurley too. Oh, how about that?
Yeah,
All right,
that,
so-
that was the last shuttle mission.
Oh, cool. Oh, I didn't even know that. So there we go. So there's Hurley and Cassidy on that patch. All right, so that's. I think we'll maybe keep on the lookout for Bursch because I saw Bursch in here before too. But other than that, I think we'll maybe just take quick glances at the patches because that's what we wanted to see, right? Chris Cassidy. So let's go to. Oh yes, we got to go to the. This is the Kibo lab, the Japanese lab. And we'll look at a couple things in here.
This is the GEM airlock,
The GEM airlock.
in the Japanese laboratory.
It's used to move
And it's
items
used
into and out of
move
the
stuff
ISS.
from inside the space station to outside the space station. Most of the time, it's small satellites that are
question, Jerry?
grabbed by the Japanese robotic arm and deployed into their orbit. Sometimes it's experiments that need to be installed outside the station, and then maybe in the future even brought back in.
But
And
it might be, I'm wondering if it might be on.
so how does it work?
I wonder if
Let's
it
say
might be on
that
your
I
end.
need to move something
I
outside.
wonder if it might be on your end
What I
because
do is, first of all, open this hatch.
it's my screen.
And then there
I'm
is a
watching it
slide
on my phone and the
inside,
screen
slide
seems to be
out
going
and
already. So
So I
It might just be
here to this
internet,
control.
Yeah.
internet issues,
And
which is
from
okay. I would
here,
try
I
and,
need to command
I mean, if it
this
does
slide
cut
to
out
go
on you, just try and get back to a live view, just because that's how we're
Then I
interacting.
have to install whatever it is that I need to move outside, for example, a small
Awesome,
satellite,
okay.
onto the
But
slide
this is
table.
just one of the
I have
airlocks.
to do that.
What do we got here? This is the, oh, here we go, the CDRA, the carbon dioxide removal assembly inside the GEM. And it works to remove carbon dioxide from the cabin air, allowing for an environmentally safe crew cabin. And of course, you can then essentially take that carbon dioxide and convert it back into oxygen for reuse. There's no point, if you can just convert the material that's already on the ISS to usable elements, compounds, that makes a lot more sense than taking up more oxygen tanks up. And that's also crucial for longer expeditions away from Earth, out of low Earth orbit. If you're going to Mars, for instance. Okay, let's see. There's another lab set up.
This here, for
Experimental
example,
rack.
is the cyborg.
So it's a number of
The
biological
cyborg is also
experiments on the ISS.
biological
The racks have a
rack
number
in
of
which we can do
glove
biological
boxes,
experiments.
microscopes,
It also
and
has a
sensors.
number of glove boxes,
And
microscopes,
lots of lab equipment
and,
scattered
it
about
also
in
has
these
a
lab
sensor.
modules.
I will also be working on the cyborg
Patches.
during my expedition to do some experiments for JAXA, for the Japanese space
Quick
station.
glances at them.
Next to it, we have the
Move
routine
on
rack.
to
The routine rack is more about material science.
yeah,
For example, for the
sometimes these videos have one of the astronauts talking, which we'll stop for a couple of them. Some of them are kind of quiet, but okay. So let's fly back into node 2. And let's see if we can pull off a Superman here. Well, actually, one second before we do that. We have a bunch of sleeping quarters for the astronauts. This is what they look like from the outside. They're basically small closets. We can't open up the doors, sadly, to see what I picked up a wrench.
Oh.
So we can't open the doors, but there is a video. I can't remember which astronaut shows us. Let's find out.
Here's one sleep station.
Oh, it's Sunny
I'm
Williams.
right now.
She shows us how these quarters work.
So I'm
I saw
inside.
her yesterday.
It's sort of like
Oh,
a
cool.
little phone booth, but it's pretty comfy. I've got a
So
sleeping
astronaut
bag
sleep
right
stations
here
are
that
equipped
we
with
sleep
sleeping
in, so
bags,
we
a
don't
computer,
have
clothing,
sort of
books,
like a
and
little
various
bit of a
objects
cover,
that
we don't
personalize
fly all
their
over the
space.
place. But you know, you can sleep in any orientation. I have it sleeping, feeling like I'm standing up right now, but like you
Okay.
saw, I'm on the floor. But it doesn't matter if I turn over.
And you can see she's showing you that that orientation
Upside down.
doesn't really
I can't
matter,
have it.
right? You can sleep standing up, lying down. There's really no change in your position, or at least your perceived position while you're sleeping, because there is no up or down. There's some cargo. Now, one thing you see in this experience is there is just a bunch of loose cargo and tools and everything just randomly spread around the station. That is not the case. They keep this stuff contained in the actual ISS. It's more just so I can have a little fun tossing things aside. But like tools that we saw, like that wrench floating around, no, you wouldn't have a wrench floating around like that in the ISS. I don't even know where it went. Oh, here it is. We'll put this back on the Velcro here. See if it stays. Yeah, it'll stay. There, we're being safe. Here's some more patches. We'll take a quick look at those before we try the Superman maneuver.
I don't know if they know what you're talking about.
Oh, they'll find out. Maybe. Let's see. Oh, these ones are really tricky to read. I don't see anyone familiar.
You're going a little fast to make me dizzy.
Oh, sorry. All right, let's see if I can fly down through this module. This is
Talk
Destiny.
about what it takes to fly.
So yeah, I'm going to use these handrails here. This is going to be my method, and it's going to mostly get the idea across of how the astronauts would go about this. They just pull themselves with the handrails, and I'll do the same thing. And when I release, I'll be propelling myself forward.
Inertia.
Yes, using inertia. And I will stay. There is air in the space station, so you could potentially slow down because of air resistance. But if you really speed yourself up, you'll go flying through the capsule. So you gotta be tame, especially so you don't have any collisions with walls or other astronauts on board. Now we'll see how straight of a path I can make with this as I fly through the Destiny module. Here we go. Let's see. Maybe I'll just try it with one hand. Usually the astronauts would use two, but I don't really want to correct my... Okay, so we got to make a fist. Let me see if I can do that. There we go. There's my fist. We're going to do the Superman. 1, 2, 3. Oh, I didn't quite get it. I went at too far of an angle. Let's try one more time. All right, one more time. 1, 2, 3. There, that's a little better. Whoa, I crashed into a wall. Almost made it through. Okay, the astronauts are frozen at that though. I think it was, I saw Sunny Williams doing that? I think it was. When I watched one of her tour videos.
Jeff Williams, he's better at it.
Oh, okay. All right, so let's take a quick tour of the Destiny module. This is the U.S. Science Lab. And you can see there's similar pieces of equipment here. There we go, let's go back to this. I explained this earlier, but this is the Capillary channel flow hardware. NASA astronaut Scott Kelly, there's Kelly who I mentioned earlier, works with capillary channel flow, experimental hardware, and microgravity science box. That's a lot of words. In the Destiny laboratory of the ISS. So this is another experimental setup. All right, we came across another piece of exercise equipment. Can you guys tell what this is? Maybe you saw an expert video. Can you see the pedal here?
Oh yeah. Doesn't look like a bike, but it is.
Yeah, and it slides right on out. I think there's a video with
Here we are
Sunny.
in the
Yep.
U.S. laboratory. Again, this is a laboratory
I told
with
him
science
that she
experience
did the
on
Boston
all of the
Marathon.
walls here. All sorts of
Oh
stuff.
yeah, I saw that. When I was reviewing this last night, I saw the treadmill and some notes about her doing
We need
that.
to do that because we lose bone density
Crew members
and
face the
muscle
loss
mass
of
while
bone
we're up
density and
here.
muscle mass
And that's
while
a
in
result of
space
not
as a
having to
result of
fight
not having
against
to fight gravity.
So,
And as a result, astronauts must exercise using a variety of equipment, including the bike and the Destiny module.
This is the bike.
There she is. I don't think she.
So all you
Maybe
need
she
to do
tries
is
it.
actually clip your feet in.
Or at least
and then
shows you
can
roughly
start
how it
pedaling.
works. One of the other things she makes note of in this video is how
Actually, I haven't said
this is a almost like a free-floating object. It's connected to the wall, but it's able to shift as you exercise on the bike. And she explains that the reason for that is so you don't apply too many forces to the hull of the ISS, because eventually those forces will propagate or move throughout the entire structure and start causing the solar panels to bounce. So in order to avoid passing those forces onto other parts of the ISS, they have to make sure that this structure here is able to move and shift along the wall. It's a really important point. So there's one of the pieces of exercise equipment. There's another patch here. I don't really recognize any names there. See about these ones. There's Collins again.
Katie Coleman. She was playing the flute yesterday.
Oh. We're just going to tour the ISS. We only have a couple more modules, right? If we have this one and then 3 more smaller ones, and then we will end with a spacewalk. There's Kelly.
I'm following with the parts of the model. On the back of your booklet, you'll see the parts are labeled. Every single module has a name, like Kaibo, Tranquility, Soraya, and so on. So as Jeremy goes through it, see if you can recognize some of those module names. Parts of the model look like this. All right.
What else do we have in here? We'll take a look at a couple
What
more.
module are we in?
We're in the Destiny still.
That's
We'll take a look at this laptop here and then move on. Oh, this is a cool video of, I earned an award apparently for exploring the ISS. Yeah. I think this is, let's see, it's off-duty time astronaut Don Pete's experiments with the physics of water. Look at that.
Yeah.
Wow, that's. I wonder what they have it that's held on there by. It looks like just some wire that the water is.
Surface tension.
Yep. Look at there goes one floating orb. That's cool. Look at that. Really fascinating. That's water in space, and I'm sure you've seen that before. But it's really cool to watch the astronauts just take this orb and just toss it in their mouth.
Okay, here we go.
It's really
Do it
fun.
again, looking into the camera.
Okay, pulling off here. What's this here? Twin studies. Astronaut Scott Kelly gives himself a flu shot for an ongoing study on the human immune system. The vaccination is part of NASA's twin study, the compilation of multiple investigations that take advantage of the unique opportunity to study identical twin astronauts Scott and Mark Kelly. So really cool opportunities they've been able to explore. Especially with having...
This is one of 2 identical robotic workstations here on ISS.
Or
The other
one
is
of
in
one,
Cupola.
yeah.
This is typically our backup
The
workstation.
robotic
From a
workstation
robotic
is used to fly
workstation,
the
of course, you
arm.
can fly the arm,
Workstation-
which means that you
workstation
can
is the backup
operate
robotic
and
arm.
control
It can be
the
used to
astronauts,
capture
the
visiting
big
vehicles,
robotic
bringing
arm
cargo
that is outside the
to
station.
support
We use it,
astronaut
for example, to
activity
capture
and to
visiting
move the
vehicles that
entire
moves
module.
cargo.
You can find the robot arm on this document right here.
There's
In
Collins
York.
again. And
So where are we going now?
so we're going to float on into the other nodes of the ISS. Let's climb on through here. Wow, there's a lot of patches in here. Let's see where we are. So we're in node 1, and node 3 is over here. So let's take a quick look at node 1. If there's anything. There's a tool bench over here. Whoops, oh geez, I flew too far. I threw my ketchup bottle.
I'm going to mute mine so it comes out better.
Okay. There's the ketchup bottle. I wonder what this is. What do we have here? Can you tell us?
Something.
Yeah, since maybe applesauce or something. All right, so here's our Velcro bench. Space food. Astronauts enjoy space cheeseburgers aboard the ISS. The distinct difference between cheeseburgers in space and those served on Earth is how they are enjoyed. Rather than a bun, astronauts eat their burgers in a tortilla. I think that's color you got me say.
Not much of a burger though.
Yeah.
I'm not, I'm muted by the way.
Okay.
So,
You'll still come over on the YouTube stream, I think.
a little bit?
Yeah.
Okay.
Yeah, it'll come over because it's just coming from that camera. You guys can stop the video if you want to take a closer look at these patches. But I'm just going to glance over them quickly.
You mean pause.
Or yeah, pause the video, yeah. And then just jump back to the live view if you find one that's interesting. Or you can always go back later. It'll save it to our channel. There's a top here. Oh, there's Birch.
Oh, Danny.
He grew up in Vestal. And when he visited, I learned that my grandpa actually taught him in school, which is kind of cool.
Your grandpa taught him.
Yeah, I taught him Spanish.
Oh my gosh. Did he teach you anything?
Yeah, a little bit. I did take Spanish in school, so he was able to help me out. Let's see. All right. So that's the patches. We'll be done with the patches for now. Here's node 3. And again, you might recognize this most easily by, well, one, the cupola, which we'll visit in just a second. But here is the lavatory. So, yep, there's Sunny again, explaining the bathroom on the ISS. Okay, good. So, you don't need to see that again. And then here's the treadmill, cosmic treadmill. And running a marathon in space like we talked about earlier. We ran part of the Boston Marathon. The completion time was 4 hours and 23 minutes and 10 seconds. Leading a marathon in space, how about that? Okay. And I'm not sure, I thought there was a little video of
As all of my family and friends know, I love to
Karen,
run on Earth. Luckily, we have the capability to run here on the space station too. In fact, it's one of the 3 exercises that we do on a daily basis to help keep our hearts and our bones and our muscles strong while we're here without the gravity of Earth affecting our body every single day. So let me show you how we do it here.
All right,
This is our treadmill. It's called T2.
On the treadmill here.
It's located in Node 3 on the International Space Station. You'll notice that the treadmill can move.
And our audio might be
Vibration
coming through better
isolation
for you
system
guys.
like all of our exercise equipment is. And the reason is
Looks like
because
a longer video,
there are a
so
lot
I
of
don't-
loads when
you
you
can of
run
course find all
on
these
a treadmill.
clips on YouTube. I don't want to take too much time watching those. All right. Go down here. We'll dive into the cupola. We'll have a look at the Earth.
That is so pretty.
I can look out the windows here. The edge of the Earth.
Looks like the radiator's hanging down.
Oh, yeah, there we go. I gotta be careful I don't fall over. I'm losing my perspective on the real world here.
Jeremy forgot he has gravity to deal with.
Yeah. There's one of the arms. I think this must be the Canada arm, right? Maybe.
It's the only arm I know of.
Okay, yeah. There's the Canada arm.
They got a new arm.
And there is there's a little experience that you can do where you operate the Canada arm and bring in a module. I'm not. We maybe can check it out after the spacewalk. We'll see how much time we have left. But I'm not going to prioritize that right now. But look at this view.
An arm on Thursday.
Oh, cool. So we'll see if we can get back to that in time. But look at this view from the Earth. Looks like we're mostly over the ocean, or is there some land down here? Oh, there's a hurricane.
Whoa.
Well, how about that? Look into the eye of the storm. I wonder what hurricane that is. There's some islands over there. There's some bigger landmass over here. Not sure where these are. Cool. All right, so that's the cupola.
A strong whirlpool? Yeah, I get it. It's definitely a big hurricane.
All right. What haven't we toured? We didn't go to the Quest Airlock yet. I think we should go there because that's where we can get on our spacewalk.
If you want to get your spacesuit on, you gotta go to the airlock.
I can do another Superman. I keep pulling myself up rather than straight, but that's okay. Oh, what's this?
Can we do a little Q&A at the end?
Oh yeah. Has anyone asked any questions in the Zoom chat?
Oh.
Yeah, double check that. See it.
Where is it? Over there?
It should be on the laptop, yeah.
It's not on the laptop. It's here.
I thought we had it up on a window on the laptop, but
Looks like Roy is going to.
oh. Should be to the right on the Zoom window.
I am NASA astronaut Chris Cassidy on board the International Space Station.
Oh, here's Chris Cassidy, all right.
Last week, myself and Luca
Astronaut Chris
Romano
Cassidy explains an effective part of the spacesuit used by fellow astronauts during EVA.
inside of his suit, if there was leaking cooling water, somehow
That's who you'll be talking to
his
tomorrow, right?
ventilation
Yes.
system and that water got into his helmet. I don't know the exact specifics right now. The engineers and all the people in Houston
I love that.
are working on the problem and trying to figure it out. We'll do some troubleshooting soon, but I wanted to show you where the water was coming from. So this is Lucas' helmet, and the ventilation air comes into the helmet through this port right here, and then goes behind the member's head, and then blows the air across the front of your face.
Some audio.
So the water,
I hear
mixture
myself.
of water and air getting into this.
I don't know if it's through these speakers
The
or
water
what,
bubbles
or
started to build
I
up
definitely hear
behind
myself
his,
coming from somewhere. I
behind
don't know
this
if
white
that's
plastic piece.
Yeah,
Once the water got big enough that it went all the way around and started coming outside the edge of the white plastic, then it saturated his communication cap, and sort of capillary flow just brought the water all around his head.
It should actually begin
And he had
microphone through there.
filled up in his ear cups, and it started to creep into his eyes.
Yep.
Covered his nose.
I was
Scary
playing the
situation.
playthrough for it.
The ground teams worked really well to give us some direction. And
Well, let's go on a spacewalk here, and then we will.
the water
Go here. Do the spacewalk. Okay, so spacewalk. Let me get my suit on. And we're gonna head outside. Oh, wow.
I need you to
Here
make
we
your
are.
way to the capsule and check for signs of micrometeorite penetration.
Oh, God.
And you can see, you
Grab
can just
onto
about
the
see my
exterior
helmet.
handbars and follow the path to get to the
My
capsule.
Inside your
computer. Yep, so I'm inside my spacesuit, and let's, just outside the airlock, let's go
Don't
float
spin
around
too
here.
fast.
Okay. So I'm gonna float
Grab onto the
around
exterior
there.
handbars
Now I have a
and follow the
jetpack,
path to get to the capsule.
but the astronauts would
Looking
be
good,
attached to
ISS.
the station.
Continue to the capsule.
There's the sun. Look at that. Looking down on the Earth.
Be careful.
Solar panels. We'll jump over this way. We'll just slowly.
You've
load
gone too
ourselves
far from
over
the station.
between the different modules. We'll look at the space station from above, or what we can say is above, right? Look, you can see the Milky Way out there. Very nice. All right, let's go a little further up here.
You've gone too far from the station. If you're looking
Oh,
for
I'm being
something,
yelled at.
it's not in that direction.
By command, they're telling me I've gone too far.
What are they saying here?
Stay focused.
Let's follow the arrow. Telling us to follow the arrow. So let's see what they're gonna have us do.
If anything goes wrong with your tether, you'll float
I'm just
away.
using my jetpack
Always
right
keep
now.
at least
I'm
one
not
hand on the
I'm
station.
not following procedure.
He's in trouble.
But you can see there's handrails out here for the astronauts to navigate the outside of the station. Here we go.
Alright. You'll need to make a pass all the way around the capsule. We'll confirm spacecraft integrity with your EMU camera.
Alright. You want me to look around the capsule here? One of the cargo
Come in,
capsules,
ISS.
right?
Something was wrong with our readings. Capsule pressurization has been confirmed. I say again, capsule pressurization is confirmed. Structural integrity is intact. Return to airlock immediately.
Oh, return to airlock. I don't want to return to the airlock yet. No, I want to go look at the.
Your oxygen supply is low. Push off the station and use your safer pack to maneuver back to the airlock.
That's the,
Your left thumbstick will activate your thrusters.
Japanese
Yep, here's the Japanese module.
eyeball.
I'm not going to follow the rules they're telling me here. I'm not coming back. I'm enjoying my spacewalk. Yeah, here's Kaibo. And
Jeremy is misbehaving.
here's this would be node 2. This is the European Science Lab Columbus. It helps to get an outside perspective too. That looks like the, is it the cargo module? The PMM, maybe?
I'm not sure. I didn't see
Looks
it when
like-
I went back.
Here it is, over on the back. It looks like it's connected to the Japanese module. Yeah, don't worry, I can't float off. I have my jetpack, I'm safe. We'll use the rails here. I'll go, this will have the actual astronauts go about. And then we'll Superman over to what I think is the PMM.
Attached to Kaibo
Maybe. This looks,
is Columbus.
yeah, the Columbus is that one, I think, over
And
there.
then the
'Cause
other
there's node
way
2. This is attached to Kaibo. JPM, it says. I don't know what that means.
Harmony.
Yeah, it doesn't have any other labels. I think when I saw this earlier, we didn't visit it, but I think this was a cargo.
I think it's JPN.
JPM is what I'm seeing on this one.
Okay.
When I visited that before, it just had a bunch of containers in it, in cargo crates and stuff, so I think that's what that was. Then we have the Destiny module. Here's lab, the Destiny lab, US lab. Climb across this. And this would be node 1. I think this is node 1, and then this is node 3. So here's node 1, node 3. And this is the airlock, Quest airlock.
And that's where you're supposed to be.
Yep, that's where it wants me to go. I'm not going to go there quite yet because, like I said, there's one part that we can't explore into, and that is the Russian modules. They are over here. We can't explore the interior, but at least we can check out the exterior. Here are the Russian modules. And it's funny how you can see when you move between the different modules, at least when I was watching Sunny explore both those ones back there and the Russian ones, the different engineering that goes into each of them from the different countries. They all have their own sort of aesthetic to some degree. But they all work together. Is this the inflated module? It looks like it's that's what that one was. Because I remember there was some inflatable.
It's not there on my diagram.
Okay.
It's Russian.
Yeah, it's one of the Russian modules. Again, these are all Russian modules back here. I'm not sure if we can, maybe we'll find the Soyuz, one of the Soyuz capsules. We'll see if we can find that. So we fly out this way. Ooh. Let's see if we can dip below. Nothing more down there, or... Not sure what that is.
Don't grab it.
Yeah. No, I don't see the Soyuz. I guess it's just the a cargo capsule over there.
But they always have one parked there.
Yeah, it's interesting. I guess I don't have any way to get home.
Emergency escape.
I don't have a way home because I won't fit in that cargo capsule. So I'm stuck here.
That would be a rough ride. Especially when it burns up.
Yeah. All right, so it's telling me to go back to that airlock, the Quest airlock, but I'm going to have one last bit of fun here. Since I have a jetpack, why not just fly away? We'll grab these rails here, and we'll just launch ourselves high above. Let's see if they'll yell at me.
Ooh.
Bye, I'm just going to go to Mars now.
Woo!
Look, it's really cool. This, just not a perspective the astronauts can get because they're not supposed to be this far out, right?
Screaming at you?
Yeah, no, I haven't gotten any. Apparently, they don't mind me floating off here. They've just decided I'm not going to listen to rules today. Look at the sky, though. Oh, there's some invisible wall here.
You're in it.
All right, let's head back to the airlock, and then, if anyone has any questions.
Okay, would you type in...
Oh, I'm flying too fast. Oh, no. I can't get back to the airlock. There it is. Okay. I just got to find it.
Well, Sharon is figuring out where he is. I don't know where he should be. We're going to take a few questions before we leave, so let's see. Questions about, how do you do 3D imaging and how do I get one of those? I don't know. Questions like that. You could type it into the chat.
There was one question from Mary from Eli. That she asked on YouTube. She says, were all of the pieces of the ISS made in one central location? Since so many countries are involved, it could get tricky with the parts made with different materials across the nation.
Oh, that's a good question. I know it was the service module. It was first, right? Is that Russian or is that American? Yeah, I don't remember. Wherever it is, I don't think we can find it. But there is like one original piece of the space station that was sent up there first. And again, I think it was part of the Russian initial program. Oh, I found water and tea. How about that, too? What's my train of thought here?
But,
I was looking at the
making the modules in different countries.
Oh yeah, so they all do work together. There's definitely some different bits of engineering between the Russian and the I guess the Western or the European and American modules. If we look around the like we are in, obviously we can't explore the Russian modules, but as we were flying around between the different nodes, the Destiny, the Kaibo, and the Columbus, those were all very similar in engineering, right? You can see that they were built almost in tandem. Like the walls are very similar. This is we are in node 3 here. Node 2 is back here. So these are NASA modules. Go back here. Here's the Destiny module, which is US built. Climb through here. Oh, I got stuck. Climb back here to the Japanese and European modules. You can see it's all very similar. So they do work together to make sure that there is parity between the modules, because otherwise, if you don't have that, yeah, you run into, I think what you're thinking about, you could run into problems, compatibility issues if you weren't working in tandem together. So these, and let's go back to the European one, see the aesthetics in there. Those ones should be very similar. You do notice some significant differences when you see the Russian ones. Like there's a flashlight. Someone left the flashlight out. Let's put it back here. Let's store it.
You can tell them that the astronauts tell me that the Russian modules smell like cabbage.
No, they smell like cabbage. I didn't know that. That's interesting. What are the rest of the modules smell like? Interesting. But yeah. So you have to have that engineering parity between the different modules, regardless of where they're from and where they were built. Everyone works together to make sure the ISS is fully compatible between all modules and all capsules that go up. Very strict guidelines. All right. Any other questions?
From Antonio, he's got a Starlink launch.
Yeah, the Starlink, SpaceX is launching another 58 or 60 Starlink satellites right now, apparently. So actually, later tonight, what you can do is you can go to your Heavens Above. You on, Mike? Yeah, you can go to Heavens Above, and the new Starlink satellites should show up there in Heavens Above.
Everybody got that? Okay, so the link is there. Thank you very much, Antonio.
Yes. Okay. The last thing I guess I wanted to mention is if anyone ever does have the chance to, because I mean I can only convey so much to you through the video feed that's showing through the headset. But if you ever have the chance to experience VR and try out flying through the ISS, it's way more fun to do it yourself than to watch someone go through it. But I thought it would be a cool perspective to show you and like have some more one-on-one communication time as with someone flying through the ISS. Now, I wasn't actually doing it, of course, but I was giving us the idea of how it works. I think, yeah.
Well, tell them that it's recorded and they can see it again later on.
Oh yeah, we do. It will be posted as a regular video on YouTube. So if you want to check it out on there, you are welcome to do so. And you can again click through the different patches that we saw. I know we cycled through a bunch very quickly, but if there was someone that you were interested in finding, you can click through the frames of the video and see if you can find someone.
And there are other space station simulators you might want to try.
Oh yes.
We're going to talk about those.
All right. Cool.
Everybody say thanks a lot to Jeremy. Yay.
All right. I'll wait to see you all in VR. And yeah, if we want to, we can close down the screen.
All right.